Hello everybody, it's Tim again. So I'm getting ready to do the alignment on the Hallicrafters S40-A, and just doing some of the pre-work before I actually sit down and start on it. So one of the first things I wanted to do was to carve out the wax that they use around the inductors or the coils, whatever you want to call them. I'll show you what I'm referring to if you get into these older radios, even some of the newer ones, but let's see if it focuses. You can see right there, and I'll go and point to it. Right here on the right. And you'll see the slug in there, and it goes all the way across. There's a couple of slugs in there. And what they do is after they adjust them, they seal them up with something that's similar to beeswax to keep them from vibrating out. Now you could do the alignment and probably leave that out because there's probably enough residual left on the threads to last forever. But what I did was I dug it out just with a screwdriver. A little screwdriver got in there and removed it all. And I'll show you my collection of what looks like earwax. Right there. So that's all the little pieces, and I'll save that. And can actually heat it back up and put it in there, or make it almost like a liquid to get it in there, or just kind of heat it with a mild heat gun. Lay it back on top. It'll go back in. But I wanted to save the original stuff. I've never actually had to buy any beeswax. I guess I could get it from Amazon. Anyhow. So I wanted to get all that out, just as a, so I don't have to dig it out later. So I got that all out of the transformers. There was quite a few of them to take it out of. So one of the other things I wanted to do too is the manual, and for most radios when you do the alignment, they want the case or some kind of steel cover back over it, because it influences how the transformers and the inductors and everything act. So I want to put the case back on, but I looked to see if there was adjustment holes on the bottom of the case, and sure enough there is, because I thought, boy, there'll have to be a lot of them. So what I'll do is, just to give you an idea, I'll be looking at this up here, and if it focuses for me, let's see if that'll, there we go. So each step, just to give you, for instance, this one step here, we'll go across step 4. An RMA Dummy Antenna, and I'll be making one of those shortly. But it tells you what to set everything to, and then it tells you what you have to adjust. And it says to adjust C20, C2, C13, so 9, 4, and 7. I'll have to see if that's really what that says. It looks like it. Yeah, 9, 4, and 7. So it might be kind of a pain in the butt to have to look that up every time. So, that being said, my plan is this. Make my computer work for me. If you look, here's the references that they give you, what all you're going to be adjusting. There's the numbers that they call out. So that's right. Let me see if I can move this down a little bit better or zoom out the camera a little bit more. So the transformers along this edge right here going up, they should coincide with the transformers right here. I'm sorry, those are, there's at the very top. See if I can get that to lighten up a little bit. It looks really dark. Let me shine some light in there. But at the very top, there's a row of capacitors, they're trimmer caps. Then there's the transformers, the inductors, and there's a couple more trimmer caps in there. I don't know how much more light this is going to actually give us. Not a lot, but anyhow, you can see the top row right here. That's the capacitors, and then the tuning inductors are down here. A couple more capacitors here throughout, sprinkled throughout. Anyhow, as you get the idea, there's a whole bunch of them. So what I found is this here. I'll put the cover up here. So right next to it I'll put the cover. And if you'll notice all those handy dandy holes right at the top. But, oops, sorry, I wanted to go the other way. Okay, all those holes. But the problem is I don't want to have to keep looking at which one's which. So what I'm going to do is I put this sheet of paper over here, cut it out, over my holes. And if you look at that, see how nicely it made the where the holes are. So I'll take a hole puncher, punch those out, and then I'll label them what their numbers are. That way when I start tuning up, I'll just be able to look and see, oh, I gotta do 1, 2, and 3 or whatever. Anyhow, so I'll take care of that too. So next time I tune in, I should be building the RMA Dummy Antenna, and that shouldn't take too long. I'll just basically show you the antenna, the completed project, and the schematic. We'll hook it up, and then we'll start through the tune-up. Okay, so now if I'm following this correctly, it's going to be a 200 condensers in series with this stuff. A choke shunted by a 400 capacitor and a 400 resistor. So here's what I come up with. But that's what I came up with. So looking at these row of things right here. So basically I have coming in, there's the 200 capacitor, and then the 400, the inductor, and I didn't have 400 ohm resistors, but I had two 200s. I probably could have used a 390 just fine, but that's what I grabbed. So just put it together on this little board next to another project I was working on. If it works okay, I'll just cut it out and keep it, because I'll probably have a whole rush of these alignments needing an RMA. So the next thing I'm going to do is get it hooked up to the radio, and we'll go from there. Real quick, I'll show you too. I know I spoke about this before. Boop, 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 boop. With the holes punched, remember I said that that would be the paper, so that it has everything called out on it, so that I don't have to keep looking back and forth. So that's it. Let me get everything hooked up, and then we'll start with the alignment. Okay, I had to take it off the stand to show you what's going on. Let me turn this down. So what I have here, it's a little voltmeter I built. It's got the maximum of 1. Okay, so anyhow, that voltmeter does 1 volt, and then I have an adjustment on it that I can kind of knock it down if I want to, but the idea was to make it a really low reading voltmeter, and you'll see why in a minute. But anyhow, if you look back here, it connects across the speakers. The speaker. I have a switch here, so for other purposes, that's got the middle position and everything's off. If I put it one way, then the speaker will work that's built in here. If I put it the other way, then a built-in 8 ohm resistor will work to take some of the noise off you. But on something like this, I'm not going to unsolder the wires. Plus it's a 4 ohm, so I'd have to put an 8 ohm in parallel with it. Oddly enough, they use a 4 ohm speaker. So what I have here now is, I'm going to put it back on the stand in a minute. I just wanted to be able to show you. There's the RMA that we built. Take that back. And it goes back into the terminals on the back here. You see where I believe it's these two are jumped. That's a jumper to ground. And then it goes, the output from the generator goes to that antenna lead. And then there's the handy dandy paper, which seems to fall off every time I walk past it. I could tape it on, but it's just a reference kind of thing. Let's see what I got. Here's that. That is fed by that signal generator right there, because that one goes up past 36 megahertz, I think might be the highest they ask for. Also, I have a frequency counter there, so you can see I'm right about 36, 39, 8, 9. So then what I'll do is I'll turn the dial here to 36, and that would be on the number 4 scale, so you can see a 35, and it's the one right past it. So we'll give it a shot. I'll show you how it works on that scale, and we'll see what happens from there. So let me put this back on pause and stick it up there. Okay, well, as you can see, there's the 35 right there, and then the hash mark right above it is a 36. Now the camera's a little bit higher than straight on, so it looks like it's a little bit below it, but either way, with these analog dials, that's about as best you can get. So what we'll do is we're going to turn everything on now and see what we get. I know it's fairly close. Alright, so there's that. I'm going to fiddle with the dial just a little bit just to see if we're even close, which I think we are. Okay, I got that straightened out a little bit. So on this one I'm going to have to turn it up loud to show you what I mean with doing the adjustment on this, so you won't be able to hear me, but at least you'll see on the meter what's happening. So the first place I'm going to go to, according to the book, is capacitor C19. So I'm going to turn it up a little bit. You'll quit hearing me, and you'll at least see that go up. Make sure it's still on it. Yeah, I'm going to zoom out a little bit so you can see a little bit better, maybe. Oh boy. All right. Here it goes. Sorry for the noise. All right, here we go for the adjustment. All right, that looks like about as good as I'm going to get it. Turn that back on, so you can see the point there is you adjust it till you get it to the highest you can get it. So then let's see, let's go to the next one real quick, and that's going to be C1. So looking at my handy dandy paper, this time you can watch what I'm doing here. Alright, so C1 is going to be right, I got to come down, it's actually below that. There it is there, it's the first one right over here on the end. So I'll turn this up again, but just so I can kind of hear it. Make sure you're still focused. See what I mean about it coming on? That one was right about there. So the next one is going to be C12. And putting this back up, C12 is right here. Seems like we might have bumped it ever so slightly. C12. I'm going to watch the meter again. And C12. Okay, so now we go to the other end of the band, and this time we're going to do 18 megacycles, megahertz, you and me. And let me see what we got to adjust. I'm looking up here at this. Whoops, going in again. So we're too much. Looks like 8, 5, and 6. So we're going to set for 18 megacycles. So the first thing I'll do is set the signal generator. So you can watch over here at this. I'll zoom in a little bit here. So we're going for 18. Oops, a little high. 19. I could probably at this point use the digital one, but since I've already got this broke in. 18. That's when it hears the harmonics. You get that a couple of times throughout. Alright, now I'm going to turn the generator way down again. Start low. So now I want to go to this guy. And turn it a little bit. I'm going to set this one to 18 also. So I got to come this way. And there's 18 right there. So let me see. So, let's see. If I knock that down a little bit, just want to see 17.99 back to 18 again. Just want to see how close we were. Alrighty. So, with it there, now we want to adjust the inductors. 8, 5, and 6. So we can go over here and let's see, can watch. Now the first one I always try and move the dial in this at the same time so I know if I'm moving the right way. But I always start, see if I can move the inductor just a little bit with my little flathead screwdriver. So the first thing we're going to is 8. I'm going to pull this off now. I know where 8 is. Still some of that beeswax in there. Not too much though. Alright. So let me bring it up there to turn this way down, apparently. This way I know I'm going the right way. Okay, so I'm back on 18 again. Now I'm going to get this metal out of there and use a non-ferrous something that's not magnetic to adjust this. I have plastic screwdrivers I can get in here with. They fit better in some than in others. It's a very big slot. Rather than turn this up real loud, I'm looking down at the meter and I can just see it move ever so slightly. I'm trying not to blow your eardrums out. So that's 8. So where's 5? 5's the other end. It's all the way over here. That turn with a bigger screwdriver. You can hear the effect that the metal screwdriver has sliding in there. Well, that's kind of interesting. That one does not appear to be adjustable. I'll have to look that up. Let me take a look here at number 5. That's what it's saying, isn't it? Looks like 8, 5, and 6, so 5. See the little picture here. 5, they're showing me being right next to the bottom to C1. Well, there's no slug in there, which is kind of interesting. I have to look into that a little more. Let me show you what I mean. Alrighty, so with the cover off, the choke assembly that's in question is this guy right here. I'm going to see if I can zoom in. You can see the one on this one right here. You can kind of see the slug there. Let me light it up for you a little bit with a flashlight. But if you look to this one over on this side, there's no slug. And that hole right there, see if I can. You can see the mounting screw at the very bottom. I don't know if I'll be able to get the light in there just right. That's it, way at the bottom. You can see the mounting screw. So what I think I'll do is I'm going to take that, unsolder the 4 wires around the end and take the mounting screw out and remove it, take a good look at it, make sure there's nothing else messed up with it, because it makes no sense why someone would have taken a slug out. And I'm assuming that the slug in this one would be very similar, so I'll pull that slug out, measure it, decide what it's made out of, and put that back in, and just finish up with what I can on the alignment. Obviously this isn't something I'm going to be able to find overnight or have, so we pull that assembly out and we'll go from there. Alrighty, so there it is with all the all the wires off. So inside here is the mounting screw. And in case you're wondering, it's been well powered down and completely unplugged for quite some time. Now let me pull this up in front so you can take a look at this. We can look at this together. Alright, so that's it. I'll have to look at it better to make sure that nothing's broken on it, but see what the story is with it. Alrighty, let's see where we're at. Here, this one here, that's all soldered back in again. Sorry, I'm moving the camera. That one's all soldered back in again. Well, I've moved over to this one. I took the plug out. It came out just over 7 turns, and I'll zoom in on the plug. And then we have to take some measurements of the plug when it lights up a little bit. You know, I think the light looks pretty good for that. So that's the slug. So let's measure it and see what we get. It looks to be not iron, but possibly that, what's that, the ferret that they make the little donuts out of for wrapping ballons. So let's see, let me get this and see. I'm trying to get everything in the picture. There it is there, and 25/64 high. Now let's see, the threads are, I'm going to zoom it out even more so you can see what I'm doing here. I want to get the threads. The threads are 47/128. Yeah. So if we rounded that up, it'd be 50/128. So there'd be 25/64, which is the same thing, but that's on a standard thread. But I don't know if that is. Okay, easy enough. I want to show you this is a 3/8 by 16. It's the standard everything heavy duty bolt. 3/8 by 16 thread fits in there perfect. So you ever have to work on one of these or do something like this, now you know it's 3/8 by 16, or I'm sorry, 3/8 by 3/8 with a 16 thread. So that takes care of that. We know what size, what it is, and it looks to be, like I said, made out of the same core that the donut cores are for winding stuff. Ferrite, I guess it is. I don't know what all was offered. There's different cores back in these days, but now I need to find one apparently. So I'm going to throw this back in and do the alignment on the one that I took out. Button it up until I find one of these cores. That's all I can do.